Hi, everybody. Good day, and welcome to some more fun with mathematics where we can be able to develop number sense. All right, this morning we would like to continue on what we have been doing. All right, now what I have here, I have two bulbs. This bulb here, this first bulb, blinks every 4 seconds, and the other bulb here blinks every 6 seconds. So obviously this one will blink first. And then after 6 seconds, this other bulb will blink. But there will be a special time when both bulbs will flash together. They will blink together. Yes. I wonder when they will be able to blink together. So to be able to do that, I say, well, this bulb blinks after 4 seconds. Then it will blink after 8. Then it will blink after 12, 16, 20, 24. And this bulb blinks after 6 seconds. So it will be 6, 12, 18, 24. And we can go on 30, 36, 42, 48. Let's go back to this bulb and see how he's blinking. 24, 28, 32, 36, and so on. Now, what we are really doing there, boys and girls, we are stating the multiples of 4 because we are counting in 4. And here we were stating the multiples of 6 because we were counting in 6 here. Alright? Now, when we look at it and we want to know when the bulb will blink together, we would be able to see, we look for what is common. Alright? We look for what is common. And here we see we have a 4 here, we don't have a 4 here. We have an 8 here, we don't have an 8 here. Oh, but look at this. We have 12 here and 12 here. So what we have here is that the bulb will blink after 12 seconds together. And if we go and we look for another common one, right? We're looking for this common. Here we see we have a 24 here and a 24 there. And we have a 36 here and a 36 there because 12, 24, and 36 are common. Right? So if we look at the multiples of 4 and we look at the multiples of 6, we will realize that the CM, the common multiples that we got thus far would be 12, 24, 36. Well, in looking at the common multiples, we can see the bulbs will flash at 12 seconds, after 24 seconds, after 36 seconds together. Alright? But the lowest common multiple of the common multiples, the lowest common multiple that we would have here, the lowest common multiple would be the 12. Alright? And from now on, you'll hear me talking about LCM. And LCM, lowest common multiple. How do you get that? Firstly, you state the multiples of the number. Then you look to see which ones are common. Common mean belonging to both. And then you look for the lowest one. So you have the lowest common multiple. Let's try another one. And this method is called the iterative or the listing method. If we had to find the LCM of, let's say, 6 and 8. Well, we state the multiples of 6. 6, 12, 18, 24, 30, 36, 42, 48, and we can keep going on. When you are listing multiples, it's infinity. It can go on forever. Alright? But the multiples of 8 would be 8, 16, 24, 32, 40, 48. And we can stop there. And what is common? What is common about the multiples? What multiples can be found in 6 and multiples of 8 as well? Well, we can see we have the number 24 is common. And we have the 48 as well as common that we have there. So from the common multiples that we would have had, the common multiples would be 24 and 48. And I guess you know it right away, which is the lowest one. The lowest common multiple is the number 24. And that's the listing method. Lastly, I would have taught you all about how to find the highest common factor using the listing method. And then I would have taught you how to find the highest common factor using the factor tree method or repeated division by prime numbers. Okay, so this is just the finding the lowest common multiple using the listing method. But since you all were introduced to dividing by prime numbers, remember prime numbers only have two factors, and we are going to divide by the so you're looking at 2, 3, 5, 7, and those are the common ones that we use in the primary school, right? 2, 3, 5, 7, and then perhaps 11 sometimes. All right, only the prime numbers. So let's try 6 and 8 again. Let's try 6 and let's try 8, and we are going to use the dividing by prime factors. All right, so look at it. So let's see. We going to divide using our rules of divisibility. Remember, we want to be very organized. So you want to start with the smallest prime number, which is 2. Can 2 go? 2 into 6, 3, and 2 into 8, 4. Yeah? But hey, 2 cannot go into 3, but 2 could still go into 4. So look at it. So when you say 2 into 3, you bring down the 3 because it cannot go in exactly. When you say 2 into 4, it's 2. See that? 2 into 6, 3. 2 into 8, 4. 2 cannot go into 3, so we bring down the 3. 2 into 4, 2. And we try another one again. And we bring down the 3 because 2 cannot go into 3 exactly. And we say 2 into 2, 1. What prime factor can we use now? We can use 3. 3 into 3, 1. And we have 1 here. So our aim is to work until we have 1s underneath. Alright? And look at what we have on the side here. We have 2, 2, 2, and 3. So we write them down like this. And we say the LCM will be 2 times 2 times this 2 times 3. And 2 2s are 4, 4 2s are 8, and 8 3s are 24. And here you have it. This is another method. This method here that I showed you here is called the iterative method. But this method here, method 2, we are dividing by prime factors. Alright, and we continuously divide until we get 1s. Alright, let's try another one. Let's try to see if we can find the LCM of 8, 8, and 10. 8 and 10. So you put down your 8 and 10. And what can go into 8? Let's say 2. Yeah, 2 could work because it's an even number. 2 into 8, 4. 2 into 10, 5. What can go again? Can 2 go into any of these? Yes, 2 could go into 4. 2 into 4, 2. But 2 cannot go into 5 exactly, so we bring down the 5. Alright? Yeah. So we try 2 now. 2 into 2, 1. And we bring down the 5 because 2 cannot go into 5 exactly. Can we use 2 again? No. Can we use 3? No. So we have to use 5. So 5 into 1, we bring down the 1. 5 into 5, 1. And what do we have? we have 2 by 2 by 2 by 5. So we write it down. The LCM will be 2 by 2 by 2 by 5. And let's work it out. 2 twos, 4. 4 twos, 8. 8 fives are 40. Okay? So I'm going to try one more with you so you'll get practice. Alright? And I'm going to try one more. Let's use a bigger number. Let's use 12 and 18. The LCM of 12 and 18. Alright? Now remember, to be able to state the multiples of 12 you might be able to, but 18 will be a bit difficult. So it is nice to know this method. So let's try it this way. 2 into 12, 6. 2 into 18, 9. What going into 6 and 9? Oh, 2 could go into 6. 2 into 6, 3. 2 into 9, cannot, so we bring it down. It cannot go in exactly. Okay. Can we try 2 again? No, because these are odd numbers. So we're going to try 3, because 3 could go into 3. 3 into 3, 1. 3 into 9, 3. And we can try 3 again. 3, yes, and 3 into 3, 1. And what do we have? We have 2 times 2 times 3 times 3. And what would the LCM be? The LCM would be 2 times 2, 4. 4 threes are 12, and 12 threes are 36. And there you have it, boys and girls. You would have learned this morning 2 methods of finding the LCM, the lowest common multiple. I have a challenge for you. There are 2 supermarkets, and every 5th customer will win a hamper. But at the other supermarket, every 8th customer wins a hamper. Now tell me, do you think you could figure out when the 2 supermarkets will be giving out a hamper together? Well, let's see if we can work that out. One will be multiples of 5, and the other will be multiples of 8. And we want to know when we'll have a common multiple. But we want to know when is the first time they'll be able to give it out together. So it will be finding the lowest common multiple of 5 and 8. So look at that. What can go into, 2 could go. We have to be very organized. 2, we bring down the 5. 2 into 8 is 4. We bring down the 5. 2 into 4, 2. Bring down the 5. 2 into 2, 1. And now we try 5. So what do we have? 2 by 2 by 2 by 5. And we get the LCM is 2 twos 4, 4 twos 8, 8 fives are 40. So here's what. When both supermarkets have 40 customers, whatever, tell it to 40 customers, they both will be giving out hampers together. Okay? So until next day, I would leave you all with an exercise to do, and blessings to you all.